In this video, I'm going to explain all 35 material inputs in Unreal Engine in under 12 minutes. In Unreal Engine, materials are the skins of the objects in the game. When you first open a new material asset, you will see the main material node. This node contains several material inputs. Each input defines one of the attributes or characteristics of the material. These are the inputs that appear on the node by default, but which inputs are available at any given time depends on the settings of the material's properties. For each input, you can either supply a single value, which will apply to the entire material, or you can use an image to supply a value for each pixel of the material. When using an image in this manner, it is referred to as a texture. Alright, so let's get started. The base color input defines the color of the material as it appears before it is affected by any of the other attributes. It uses three float values, known as a vector, between 0 and 1 to define the red, green, and blue components of the color. Like any other material input that accepts vector values, you can supply it with either a single vector value to define the attribute for the entire material, or with a color image to define the attribute for each pixel. The metallic input defines whether or not the material is made of metal. It is defined with a single float value between 0 and 1, with 0 meaning the material is not metal and 1 meaning the material is metal. Values between 0 and 1 can be used to create a dirty or rusty metal material. Like other material inputs that accept float values, you can supply it with either a single float value to define the attribute for the entire material, or with a grayscale image to define the attribute for each pixel. The closer a pixel is to pure black, the closer its value is to 0, and the closer it is to pure white, the closer its value is to 1. The specular input uses single float values to define how reflective a material is, with 0 being completely non-reflective and 1 being fully reflective. However, most objects in the real world actually reflect light the same amount, the amount represented by the input's default value of 0.5. So the difference between, for example, a rock and a mirror isn't the amount of light they reflect back, but how evenly they reflect light back. And that depends on the object's roughness, which can be defined using the roughness input. The closer this input is to 0, the smoother the material will be, and the closer it is to 1, the rougher the material will be. The anisotropy input is used to create anisotropic surfaces, which look different based on the direction that light hits them. Brushed metal, optical discs, and suede are some examples of anisotropic surfaces. The characteristics occur because of a repetitive pattern of roughness on the surface, such as the grooves of the CD or the fibers of the suede. These patterns are defined within Unreal using the tangent input, while the anisotropy input defines the strength of the effect. The tangent input accepts vector values, where each vector defines an actual vector in 3D space, which specifies the direction light should reflect at that point. The anisotropy input accepts float values between -1 and +1, where 0 will cause there to be no anisotropic effect, 1 will cause the strongest effect, and -1 will cause the strongest effect in the exact opposite direction. The emissive color input is used to provide the material with a self-illuminating or glowing color. Just like base color, this input accepts vector values, but unlike base color, the individual float values of the vector can be larger than 1, and the larger their values, the brighter the color will glow. The opacity input is used to create transparent or see-through materials. To enable the input, the blend mode property must be set to translucent. Once enabled, the input will accept float values between 0 and 1, where values of 0 will be fully transparent and values of 1 won't be transparent at all. The opacity mask input is similar to the opacity input, except it can't make materials partially transparent, only fully transparent or fully opaque. The advantage is that it renders a lot faster than using the opacity input, so you would use it for any materials that you need to create holes or gaps in. The normal input is used to define the normal vectors of the surface of the material. In geometry, a normal refers to the vector or direction that is perpendicular to the surface of an object at any given point. So this input accepts vector values where each vector represents the direction of the normal vector at that point. Using this input won't actually deform the surface of the mesh that the material is applied to. What it does is use computationally inexpensive lighting tricks to make it appear that the normals of the surface have changed. And so the point of using this input is to be able to add lots of small details to objects in an efficient manner that won't slow down frame rates. The world position offset input, unlike the other material inputs, will deform the mesh that the material is applied to. What it does is move the location of the vertices of the mesh, which are the points at which the mesh's polygons meet. Its most common use is to give a mesh a small amount of ambient animation. For example, it's commonly used to give foliage, like grass and leaves, a small amount of movement that makes them look like they are blowing in the wind. The input accepts vector values, where the 3 individual float values define how much each vertex should move along the x, y, and z axes respectively. The subsurface color input, as its name suggests, is used to provide the material with a color that should appear just beneath the surface of the material. Some real-world examples of materials that exhibit this behavior are ice, where a little bit of blue is seen below the surface, and skin, where you can see some of the red of the blood that is just below the surface. To enable this input, the shading model property must be set to either subsurface, pre-integrated skin, or two-sided foliage. The custom data inputs are used to provide values for custom shading models. So if you know how to code in C++ and understand computer graphics programming, you can alter Unreal Engine's source code to program your own custom shading model. And then you could program these custom data 0 and custom data 1 inputs to receive values for your custom shading model. The ambient occlusion input is used to create the shadows that are produced from indirect lighting, meaning light that has been reflected off another surface. However, Unreal's new lighting system, Lumen, creates these shadows automatically, so this input is mainly just for backwards compatibility with older projects. The refraction input is used to simulate the phenomenon in which a light wave changes direction when it passes from one medium to another. This effect is commonly seen when objects get submerged in water. To enable the input, the shading model property must be set to single layer water, and the refraction method property must be set to something other than none. The pixel depth offset input will cause the pixels of a material to be drawn at a further distance away from the camera than they otherwise would be. The value of the input specifies the number of units the pixel should be pushed. The pixels will be pushed away directly in the direction that the camera is facing at that moment. The shading model input allows you to define what the shading model is within the graph, instead of just hard-coding the setting through a property. To enable the input, the shading model property must be set to from material expression. The surface thickness input is used to define the thickness of the geometry that the material will be applied to. It's only needed when the surface will be extremely thin, such as with foliage, cloth, etc. To enable the input, you must have substrate enabled, which is Unreal's new experimental system for defining materials. The front material is also used with substrate, and is used to connect a substrate graph to the material root node. The clear coat input is used to simulate a thin, translucent layer of film over the main surface of the material. The input defines the thickness of this layer. To enable the input, the shading model property must be set to clear coat. The clear coat roughness input defines the roughness of the clear coat layer. The ClearCoatBottomNormal input is used to define the normals of the material underneath the clear coat layer. This is because when the shading model is set to clear coat, the regular normal input is used to define the normals of the clear coat layer. The input isn't available on the main material node. It can only be accessed through a node of the same name. To enable the input, the ClearCoat Enable Second Normal property, which can be found in the project settings, must be set to true. The scatter input is used with hair materials and controls how much light penetrates the surface and scatters within each strand of hair. To enable the input, the shading model property must be set to hair. The backlit input is also used with hair materials and controls how much light that shines from one direction can be seen through each strand of hair from the opposite direction. The Fuzz Color input is used with cloth materials, and is used to set the color of the thin layer of fuzz across the surface of the cloth. To enable the input, the shading model property must be set to cloth. The cloth input is also used with cloth materials, and specifies how much the fuzz should cover the underlying surface, with values of 0 specifying no fuzz, and values of 1 specifying that the fuzz should cover that area completely. The iris mask input is used with eye materials, and specifies how deep the iris is, which affects the angle at which light will refract. To enable the input, the shading model property must be set to eye. The iris distance input is also used with eye materials, and specifies how concave the iris is, meaning how much it curves inward. The TransmittanceColor input is used to set the color of thin, translucent materials. This input is not on the main material node, and can only be accessed through a thin translucent material output node. To enable the input, the shading model property must be set to thin translucent. The ScatteringCoefficients input is used to define how much different colors of light will scatter within water. This input is not on the main material node, and along with the next three inputs, can only be accessed through a single layer water material output node. To enable the input, the shading model property must be set to single layer water. The AbsorptionCoefficients input is similar to ScatteringCoefficients, except it defines how much each color of light should be absorbed by the water instead of scattered. So the higher a value is for a color, the less it will be seen in the water. The PhaseG input controls how anisotropic the material is when it comes to light reflecting off of the surface of the water. So with this value at 0, the material will be completely isotropic, meaning light will reflect off of the surface in the exact direction of the surface normals. The higher this value is in the positive direction, the more the angle of reflection will increase towards the light source. The ColorScaleBehindWater input controls how much light is reflected back from the surfaces below the water material. The effect that this produces is known as caustics, which in the case of water produces an effect like this one, where you see patterns of light and dark due to the ripples on the surface. The customized UV inputs are used to pass custom texture coordinates to the material and have them run in the vertex shader as opposed to the pixel shader, which is more efficient in certain situations. To enable the input, the num customized UVs property must be set to a value greater than 0. Alright, so that was all 35 material inputs in Unreal Engine in under 12 minutes. If you'd like to learn about material inputs in greater detail, check out the Materials and Textures section of my Unreal Engine Intermediate course. You can find links and promo codes in the description below.